coming out. Let's switch to the next presentation. The speaker is Professor Olesen.
Okay, thank you. Okay, now it's on. Thank you. I'm going to talk about an European standard and an ISO standard dealing with the requirements to the indoor environment, both air quality, thermal comfort, lighting, and acoustic. And they are very similar, up to 90%, and both are now undergoing revision. I'm going to talk a little about what's inside and what issues we will deal with during the revision. The standards were developed, the European standard was developed as one of the mandated standards related to the Energy Performance Directive. And then in parallel, the ISO was developed. At the same level, it was decided not to use the Vienna Agreement to get an ISO-EN standard, so that's why we have two. And the standard, they are accompanied by a technical report or guideline, more on how to use the standard and more information. It has now been decided to revise them, but also to split this revision on more technical committees. So the lighting and acoustic part was not very detailed in the standard, so we will have TCs dealing with lighting and acoustic who is going to develop these parts. The ISO level is foreseen that the revision will be part of this 52,000 series, which are dealing with energy performance of buildings. Supposed to be 52,007, where on the European level it will get a new number. The TCs that will be involved, I'll here mainly focus on the ISO level, that because we are here outside Europe, is ISO TC163. There is a working group, which is a joint working group between TC163, dealing with building, the building windows, insulation and so on, and ISO TC205, which are dealing with building systems. And there is the joint working group, Energy Performance of Building using a holistic approach, and a task force under that has developed the standard and is going to now start the revision. Together with TC247 on light and lighting, and also ISO TC43 on building acoustic. So the standard was already you could say in different parts, there were different sections dealing with thermal comfort, indoor air quality, lighting, and acoustic. It will still be like that, but it will be more separate part of the same standard. So it's still the plan to issue it as one standard, but the different parts are developed by different TCs. The standard for most of the recommendations is so that, for example, in the European standard we have an annex where we have default values or recommended values, so they are not normative. But countries are asked to make their own annex in the same format with the values they want. They can use the default or recommended, but they could also do changes. We put up the different levels, both for thermal comfort and also indoor air quality, in categories from 1 to 4. So we have 1, you will have some stricter requirement. For example, you would require more ventilation or more narrow range of temperature. Now I'm going to skip here the thing on thermal comfort, as we are mostly interested here on the ventilation and the indoor air quality. So the criteria for indoor air quality in the existing standard, and it will be almost the same concept, we don't know for sure, we just started for the revised. It's standards which has been around on European level. There's a previous standard before that which has about the same content. So the requirements or the recommended ventilation rates are mainly based on comfort, perceived air quality. There's also health criteria, but there has been very little focus on what the implication is on productivity, people's productivity, and the energy use of building. And there's been nothing on cross-contamination or ventilation during a pandemic. And the intention is to include some of that. But Benjamin, you don't have to read the new sections there. So the indoor air quality, there's basically a free method, and they're all dealing with how to, in most cases, establish a ventilation rate that will take care of the pollutant sources you have in the building. We have a method 1 based on perceived air quality, and then we have a method 2, which is basically a mass balance, focusing on using limit values for individual substances, and then we have just table values with predefined ventilation rate for different types of spaces. The concept for the calculation of the design ventilation rate is, those of you who know ASHRAE 62.1, is basically the same concept. We have emission sources from people, and we have, let's say, from the building, furnishing, interiors, other interiors emission sources. And for each person, we defined liters per second per person, a minimum rate. So we have to know the number of people in the space, and we then have also value per square meter of the space for the building part. And this, we then calculate what are the required ventilation rates or outdoor airflow rate in the breathing zone. To help doing that, we have criteria for the people part, how much we need to ventilate per person for a given acceptability. For example, the ASHRAE standard is dealing with 20% satisfaction level, or less than 80% dissatisfied. This corresponds to about category 2. So what we are then using for the different categories is somewhere between 2.5 for category 4 and up to 10 liters per second per person for category 1. And I should say here in the ASHRAE standard, they are more designing for people who are already adapted to the air quality in the space. So they only use 2.5 liters per second per person for the people part. So you will see that we recommend higher ventilation rate using this standard. Then there's the building parts. We have introduced then also a rate in liters per second per square meter, and this is not so well defined as the people part. The people part, we have several studies showing the relation between people dissatisfied and the number of liters per second per person. while for the building emission, diluting building emissions, the background material is not at the same level. However, there are more and more requirements to building products. There are more testing on emissions, more standards for testing. So we think in the future you will better be able to evaluate what category of building you have, if you have a low polluting or you have a very low polluting. Most new buildings will be about here. These non-low polluting building is really old building where there may have been tobacco smoke earlier. So we are often talking about these two categories. And then we have introduced a minimum. No matter what you come up with, if you calculate for category 4, or you may come up with a rate lower than 4 liters per second per person. The standard says the minimum you must have at least 4 liters per second per person. So you combine these two. Yeah, here's just some help in judging if you are low emitting or very low emitting, depending on the, for example, emission of VOCs from some of the materials you are using. We are going to update this because there has been developing of the standard and testing method for materials. So that's one thing we're going to look at, better data for the building parts, and there's a gray area to decide which building type you can use for estimating the required ventilation rate. Now, to get the supply air ventilation rate, we also have to look at the ventilation effectiveness. Complete mixing is 1, so whatever, so basically the same, the total ventilation is the same as the supply. So the breathing zone is the same as the supply. But there may be others where you could ventilate more efficient. We know about displacer ventilation may have a 10-20% higher efficiency, and when we go to talk about personalized system, I'll come back to that, it may be even higher. So this is taken care about in the efficiency value, which is the system component. If you now take a 10 square meter office space with 1 person, we can see we normally recommend to design for category 2, 0.7 liters per second per square meter for a low pollutant building, 1 person 7 liters per second. So you get for that room a total ventilation rate of 14 liters per second. You can express that as liters per second per person or per square meter. Both of them have the same air quality, it's just in different units. So, and this you can do then for other spaces. It has been done in the annex. So here's a single office where if we went to category 1, we will have 20 liters per second per person. If we go, I don't think you can. If you go down here for a conference room and design a category 4, I don't think you can. You can see it there at the bottom. There's a parenthesis and 4 behind, because that shows in this case you have reached the health limit, so you might use 4 liters per second 4 liters per second per person. So if we make a comparison, just now here again taking the single office, which is a simple case, and for example compare rates with a low polluting building then and with the ISO standard 62. So you see there is about factor 2-3 higher recommended ventilation rate using the both the ISO and the SEN than we see the recommended in the ISO 62.1. I mentioned this 4 liters per second per person, which at the moment is a minimum. It can be discussed, should it be higher? It probably will not be lower in the revision. Then there's also the method 2, where you look at specific pollutant substances, where you need to know emission rates in the building, you need to know what is a health or comfort limit for given substances. This one is also used where you use CO2 as a tracer. So more looking at the comfort. So CO2 is introduced, you need to know the concentration outside, what is emission from the people, and then you can use that also to calculate the ventilation rate. At the moment, for substances, we are referring to the WHO guidelines. We would like to have more substances. At the moment, we are not talking at all about particles, but that's something being discussed to include also in the standards. One of the issues is that the comparison between method 1 and 2, if you're using CO2 as tracer for people, is that they don't give the same level of air quality. They accept higher CO2 levels in method 2 than we would do in method 1. So that's something that we have to look at. For example, and another thing also, using CO2 is important because the issue with CO2 is important because we often use that for demand control. And people think if you put it at 1000 ppm, no matter what type of space, how many people, we give the same level of air quality. But that's not the fact. Because we have also emission from building. The CO2 is linear with the number of people, but not with the emission from people. So if you had a... let's go back. So if you had a very low polluted building and wanted with CO2 level corresponding to category 2 in a single office, it would be 529 ppm above outdoor. In the standard, we always talk about CO2 above outdoor, which is the correct number or KPI you want to use, not the absolute value, because outdoor may change a couple of hundred ppm. But if you had a conference room, you would go up to 700 and... Is it because I'm in a hurry you changed the slides for me? You will go up to about 722. So bear that in mind when you use demand control on CO2. So this is some of the issues that we don't, they're not always consistent, method 1 and 2, and especially using CO2 for demand control, we have to be a little more clear about the issues. Also, we are talking about air cleaning in the standard. It's briefly mentioned in the mandatory part. In the guideline, we are going more into detail how air cleaning technologies may be taken into account. And this is another part which we in the revision will work with in more details. Then we come to the risk-based ventilation design, where we haven't got anything at the moment in the standard. There has been done work all over the world during or after the pandemic related to ventilation. So we have at the moment a suggestion to put in some calculations on a higher ventilation rate to lower the risk. We are not talking about the first 1.5 meters from the person, but from an infected person, but further distance. And we want to see the risk calculated by a higher ventilation rate and a lower ventilation rate. There is a paper that has been worked on by RIVA. There's also a Nordic Ventilation Group has been involved in establishing a method basically based on Wells Riley. There's also some factors that could take into account air cleaning and masks. There's a paper on that. I will not go into the detail on the different, but of course there are several assumptions made in such a model. But what it turns out is that in many of the cases that have been calculated, you get close to what we recommend for the category 1. So it could be basically we say to lower the risk during a pandemic, we would recommend to design for category 1. That doesn't mean you need to run the system all the year, but only if you have incidents, you would go up to the higher level. But that's what it indicates, that the category 1, you are close to what this will calculate. Then finally, we also have at the moment in a annex something on personalized systems. There is an annex meeting at the moment going on here in Tokyo on this, and especially for cross-contamination and so on, the ventilation part is very important here, because you may lower the risk for cross-contamination if you have direct fresh air at the working place, and you may need less fresh air than if you have whole space ventilation. So this is something that, based on also what the annex is working on, we will include probably more in the revision of the standard. And here especially it is how to show that your ventilation effectiveness can be higher than 1, maybe up to a factor 3, some of the measurements showing. So how efficient and how little entrainment you have of room air before it reaches the breathing zone. So this will be worked on in the annex in parallel with the revision of the standards. So at the end here, we can say that there's requirements when you're using CO2 for method 2 with the levels of ventilation you get from method 1. That's not consistent. We have to look at that. We will need to look at particles because it's also been shown here particles is a very important substance in the indoor environment. We would also like to have other substances that are necessarily included by WHO, but we are not the one who can set those limits. It has to be some other authorities who issue those. Demand control ventilation, we have to make more clear it may require different set points because it will be influenced by occupant density. And also if you can't partly substitute by air cleaning, you also will have another setting of your CO2 for demand control. The ventilation and cross-contamination issue, I mentioned we have a model that we were planning to include, personalized environmental system. We will need to see if we have better data on this. And then finally, we would like to have, especially for thermal environment, but also for the ventilation, some KPIs based on yield performance. One of the problems we have with the indoor environment quality is that we have many parameters, but we haven't got anyone we directly compare with the energy. The energy kilowatt hours per square meter per year, we need a value for the indoor environment, which we can compare with the yield value for energy. And we are working on that. I had some suggestions here for the thermal environment, but we also need to look what can be done there for air quality. So, thank you.
Thank you very much. Any questions or comments? You also can ask a question at the discussion session. No questions, please? 一番後ろ。あ、失礼します。遠いところにしか行けない。
Thank you very much, Professor Olesen, for your comprehensive presentations. In the presentation, you refer to in the period of pandemic, the category 1 would be recommendable to determine the outdoor air flow rate, I think. But how do you think about the filtering effect? I think the filtering is also effective in reducing the cross-infection. So
Yes.
how do you evaluate that kind of effect to reduce the cross-infection in rooms?
Yes, there is a group of standards related to ventilation under that number, and one of them are especially dealing with filters and particle removal. And we have, because in this standard, we don't, for the indoor environment, we don't go into the systems. We look at the requirements seen from the occupant's point of view. And the other one are looking at systems. So we have to make sure, because you're right, for ventilation, that particle removal or filtration is an advantage. So I don't know how we want to deal with that. Probably we will recommend using certain filters, but refer to another part of the group of standards.
Thank you.
Hello. How do I self-identify how polluting my building is?
Yeah, I think you see, I don't think you can identify how polluted your building is.
So how do I know which column to choose?
That's for the building part. That's a gray area. But they are coming. I mean, they're coming more. Let's say certification of materials. So you could say, have you used material which has this certificate? You can go into the low polluted building, but it's great. So, but on the other hand, putting it in, putting some emphasis on it, so people they know whatever you put in the building will have an effect on people's indoor air quality, and may require higher ventilation.
Okay, I can see why that would work. So if somebody, say, conformed to the well standard, they might then choose the low emissions. Yeah, okay, great, thanks.
Thank you very much. Let's take a break. 30 minutes is okay. We'll come back in 30 minutes. Thank you for your cooperation.